Hi everyone, my name is Rafaela Ferreira. I am a master's student at the University of Campinas, São Paulo, Brazil, and I will present my work for a fourth EPIC conference. My work's title is Study of Commercial Coating of Pipes to Improve the Flow of Emulsions. And this work is a work in progress and is being developed for me, Maria Victória Cunha, Carlos Eduardo Perles, Vanessa Cristina Bizotto, Antônio Carlos Bannwart, and Marcelo Souza de Castro. So, exist different oils with different characters and properties, and to classify whether an oil is light or heavy, it's necessary to know the value of the fluid APE grade. A heavy oil, for example, is characterized by having a low APE grade and high viscosity. Emulsions is the mixture of two immiscible liquids, and this mixture have a high viscosity. And this can be a potential problem for production and flow assurance because of the greater resistance capacity of the fluid to flow. So, the high viscosity of a fluid is directly linked to the pressure drop in a system. So, there are some methods that can be applied in order to minimize this effect caused by viscosity. One of them, very well known, is the annular flow. Annular flow consists of the formation of a thin ring of a lubricating water at the tube and wall surface, allowing the more viscous fluid, in the case oil, to occupy the central part of the pipe cross-section. Another method is chemical additives, because that can alter the adhesive properties of the involved fluids. And the last one is the utilization of hydrophobic or oleophobic material as internal coating of the pipes. In the case of an internal coating, some important properties must be analyzed, such as the wettability of the material, which will determine whether the surface is oleophobic or hydrophobic. And this information is obtained by measuring the contact angle. If the contact angle is less than 90 degrees, the surface is considered wettable by the fluid, and if the contact angle is greater than the 90 degree, the surface is not wettable by the fluid. And another important property for this analysis is the effects of ruggedness on the flow. Raw pipes tend to present a high value for the pressure drop due to the drag of the fluid on the surface. It also has a relationship with contact angle and can be used as a mechanism to change surface wettability. Therefore, recent studies suggest that coating can be an efficient mechanism to reduce pressure drop due to changes in surface wettability and consequently in the contact angle. Kiel et al. Experimentally show the relationship of the angle with the reduction of pressure drop present a specific value of 39.9 degree for better reduction in a pressure drop. Therefore, this work aims to study the relationship of the contact angle with the pressure drop and to analyze the efficiency of the coating to minimize this effect. Okay, now I will introduce how we performed these experiments. So we used the PAT1M interface tensiometer equipment to obtain the contact angle measurements. So we performed the tests under different conditions at temperatures of 25 degrees Celsius degrees, 35 Celsius degrees, and 45 Celsius degrees. We used two different surfaces, one coated and other uncoated, and the fluids used are crude oil and formation water. After reaching the desired temperature, the drop of the fluid is injected through a needle under the surface. After the droplet stabilizes, the measurement is started and measurements are taken within 10 minutes. Triplicates were made for each system set. So these images were taken from the tensiometer, where the contact angle measurement for an air system is performed, where US is uncoated steel and CS is coated steel. The fluids represented in this image are oil and water A. Both surfaces show to be more weightable by the oils in comparison to the produced waters. The comparison between US and CS steel plates indicates that the US steel surface is more weightable for both oil and water phase. Over 35 Celsius degree with US steel was not possible to measure the contact angle for the COB oil because the low value is below the instrument limit. So both US and CS surface show to have more affinity by the oil phase, oleophobic. And comparing both surfaces, the coated surface, CS, caused a reduction in the weightability of the surface, more significantly for the crude oils, what may indicate a better condition to reduce the drag with the surface. Tests under flow condition will allow the assessment of the impact of the contact angle change on the drag reduction. And next steps, we will study of the coating in pipes in flow loop to evaluate the efficiency in drag reductions. We will evaluate to the mechanical resistance of the coating under flow conditions. And I would like to thank you for Unicamp, Equinor, FAPESP, ANP, Alpha, Cepetro, and FEN for all support given to my research. Thank you. Bye.